right, today in class we talked about slope, and there's a lot to talk about with slope, but what I want to focus on for day one is that it describes the steepness of a line. In fact, more importantly, in context of what we've been talking about, is we want to know how fast does my pattern grow. Okay, so those two are talking about the same thing. So for example, if we looked at a pattern problem and we looked at the x-axis as the figure number and then the y-axis represented the number of tiles. So let's say let's say figure 0 had 2 tiles, figure 1 had 5 tiles, figure 2 had 8 tiles. Okay. And I'm going to go and just fill in the numbers in here. All right. And so our pattern is growing like that, and we looked at today that we can model this using a line just by connecting it into this continuous figure here. All right. So now, if we wanted to find out how fast this is growing, we drew this little triangle here and said, hey, look, I can talk about it grows up 3 for every figure number. So it grows 3 tiles, 1, 2, 3, count the spaces, goes 3 tiles for every 1 figure number. And we could also draw another triangle. We could even draw a bigger one like that, as long as we go from dot to dot and then count the spaces. So if we look at the bigger triangle, we can count 1, 2, 3, 4, 5, 6. So this one grows 6 tiles for every... Now we have to be careful because we went over 1, 2 spaces. 1, 2 spaces for every 2 figure numbers. Now, this idea of slope comes in when we want to represent this situation as a number. So growing 3 tiles for every figure number can be represented as 3 over 1. Growing 6 tiles for every 2 figure numbers could be represented as 6 over 2, which you know reduces down to 3 over 1. It's the same figure, so it really doesn't matter which triangle I'm looking at. All I care about is I'm looking at how fast this is growing, and I can always reduce it down to how much does it grow for every figure number. So it goes 3 tiles per figure number. This, in fact, is the slope that describes this line, the steepness of this line. So we looked at it in the notes today. They use the change in y over the change in x is one way to think about it, right? How much did it grow on the y-axis compared to the x-axis? And this is also known as your slope. So this idea of slope, how fast something grows, what's the steepness of the line, those are all the same thing. And we're going to look at even more ways of expressing slope and the role of slope as we go throughout this unit.